Welcome to the webinar. Thanks very much for joining us. Given that there's going to be a few people switching over and getting Zoom started up, we're going to give them just 1 minute to join us, and then we'll get started. All right, let's get started. Welcome to the Wiliot Technology in Action webinar. Thanks so much for taking time out to join us. And today is a pretty special occasion for us. We've done quite a few events and communicated a lot about our technology, but we have loads of requests for people to understand what's actually happening when the technology is deployed. What happens when Wiliot goes into action with customers? And that's what this session is all about. We are going to be talking about a couple of partners and customers. I'm going to start the session off just with a quick recap of our technology for people that are new to what we're doing. But most of this session is going to be all about how our technology is actually deployed. The first speaker is Brian Merkling, who is the CEO of ThinAir. This is a really well-established IoT, RTLS, end-to-end solution provider. And they're going to be discussing a use case which is live. It's scaling to over 1 million tags, and it's in the aerospace industry. So you'll hear about ThinAir's platform, how it works with our platform. You'll hear about the use case that has been deployed. And then next up, we've got Cassie. I love Cassie because they make automation equipment, which is deployed by retailers and pharmacies and e-commerce companies. And whenever you go on behind the scenes tours with this sort of company, you see amazing equipment that's used to streamline the flow of products and packages. And that's what Cassie do. They make the hardware, they do the industrial engineer, and they integrate the electronics, in this case, Wiliot's systems. And they're doing that for some really large customers of ours. This was a partnership that was brought together by our customer. And at the end of that, you're going to have a chance to hear some interactive discussions with both Jonathan and Brian. And that's going to be chaired by Matthew Hoffman, who is our Vice President of Customer Success. So he has got his finger on the pulse of all of our deployments. And so I think you'll find that very interesting too. So before we get there, then you'll get a chance to hear the latest about our technology. We describe what we do as IoT pixels that power our sensing as a service platform. And given the nature of what we do, postage stamp sized computers that cost pennies using very low cost infrastructure, this is an opportunity to scale IoT from billions to trillions to something that we call massive IoT, and bring intelligence to food products, pharmaceutical products, clothing, in fact, every single thing. This is pretty ambitious, and there's a lot of work that has been funded by some amazing investors. You can see all their logos here, and they range from a couple of the largest e-commerce companies in the world, Amazon and Alibaba, some really large telcos, Docomo and Verizon and SoftBank, the biggest food production company, PepsiCo. M Ventures is the investment arm of Merck, the German pharmaceutical company, Maersk, the shipping giant, and then Samsung and Qualcomm on the semiconductor side, Avery Dennison, the leader in smart tag, and then some amazing financial investors. So before we talk about the technology and where we're going, let's talk a bit about what the context is of this. And these postage stamp size computers are really the latest evolution of something that's been going for decades. It started with mainframes. There were thousands of mainframes, and then we had millions of desktop computers, billions of smartphones, and now we're evolving to trillions of postage stamp size sensors that are secure and that communicate with infrastructure that very often is already there. And we're building on a lot of work that's been done in the Bluetooth ecosystem, the RFID ecosystem. But what we're doing is different to RFID. This technology was born with the cloud in mind. So rather like a Tesla, we can upgrade functionality and offload functionality to the cloud. That gives us flexibility to do new things with existing products in the field. And what we're talking about is not a snapshot. It's not a batch read or once a day or once a month of what's in a location. We're talking about real-time, continuous monitoring of everything all the time. And so the status is continuously updated. And that's really important if we're going to take efficiency and automation to the next level. And it's not just an ID. Every Wiliot tag is able to sense temperature and a variety of other things that we're starting to turn on. We deployed our tags on vials of vaccine that could sense whether the vaccine was diluted and how full the container was, as just one example. All of this is secure, it's private, and it means whoever owns the tag owns the data. And this is a great foundation for making sure that consumer rights are respected as this technology flows from production through to distribution into the hands of consumers and into their homes. And again, it's using existing infrastructure. So we're not talking about spending tens of thousands, hundreds of thousands, or millions of dollars for infrastructure. We're talking about tens of dollars for a device that can read the signals and relay them to the cloud. So all of this means that we can scale from an internet of connected things that was based on the internet of expensive things to the internet of everyday things that are meaningful and useful and can automate everything around us using these pixels that really do look like postage stamps, but they have an antenna. They can be attached to existing products, and they have the circuitry and the antennas to capture energy from 2.4 gigahertz, the frequency that all our Bluetooth devices use, sub-gigahertz, which is a frequency that's used by RFID. And in fact, we can use the energy from legacy RFID infrastructure and LoRa and other such radio technologies. And at the heart of that is the chip that has been redeveloped from scratch to be super energy efficient. And that's what makes a battery-free Bluetooth Pixel work. Just a few weeks ago, we announced a forthcoming product that takes that same ultra-efficient chip and combines it with a very, very small battery, smaller than what is conventionally used in coin cell devices, something that's lower cost, that's smaller. It's the size of a business card, actually smaller than a business card, and doesn't have some of the environmental issues that go with some of the lithium products, and is at a price point that is between $1 and $2. So very often an order of magnitude cheaper than what we see from conventional battery products. But it's still a step up in terms of the ultimate product, which is battery free, which is almost an order of magnitude lower in cost. Both of the battery assisted and the battery free product use the same chip, has the same range. It's just that one sources its energy from this this tiny printed battery. It has a lifespan of 4 years, whereas the battery-free product essentially continues whilst the structural integrity of the tag continues, which could be a very, very long time. They both use Bluetooth. The battery-free product has a fixed broadcast rate once every 4 seconds. The battery-free product varies. If it's close to an energy source, it can broadcast a couple of times a second. And as I said, one's slightly smaller than a business card. That's the battery-assisted pixel, and the battery-free product is smaller than that. So it's a computer the size of a postage stamp. It runs software that we've developed for optimal security and sensing and flexibility. But the Wiliot software also runs on the edge, and it runs in the cloud. And it's really the thing that allows us to manage privacy and manage data ownership. Without that, then we wouldn't be in a situation where privacy and data ownership would be respected, and we wouldn't have this ability to do the dynamic updates. At the end of the day, it's all about applications, and there's a number of options about how you build your applications on the IoT pixels and the cloud that manages them. There are choices. You can use web services APIs. You can use third-party apps like the one from Thin Air that we're about to talk about. And coming soon will be what we previewed and is available in controlled release, our automation platform, which is a drag and drop interface that allows you to drive triggers to a library of existing applications based on what happens with location and sensing triggers. So the possibilities are endless. This really is changing the way products are made, the way they're distributed, the way they're sold, the way they're used in the home, the way they're reused in the circular economy, and then finally the way they are recycled. So that is the recap of what we're doing with Wiliot. Now it gives me great pleasure to hand over to Brian Merkling, who is founder, CEO of Thin Air. They are an amazing end-to-end solution provider, and they have really scaled our solution for one of the biggest aerospace companies in the world. And I'm really looking forward to hearing what Brian has to say. Brian, over to you.
Thank you, Steve, for the introduction, and we appreciate Wiliot inviting us to participate in this webinar. We're coming to you today from Dallas, Texas, or what feels like the surface of the sun. I've never heard of a cold front dropping temperatures from 107 degrees to 103 degrees until this weekend, and that actually happened. So we're a group of entrepreneurs, technologists, and PhDs who deliver IoT at massive scale. Our technology is trusted by leading organizations like Lockheed Martin and other titans in manufacturing, defense, and retail. Thin Air provides high-scale, real-time location and application data, as well as AI-backed business insights from data generated by millions of valuable assets and raw materials. The best way to understand the power of the Thin Air and Wiliot partnership, or what we call Thin Air plus Wiliot here, is to see the impact on customers and on live customer use cases. One of our customers started their IoT journey with us, focused strictly on location, with a signed backlog that is the envy of the business world. Tens of billions of dollars in backlog that they needed to burn down by improving efficiency throughout the manufacturing process. So working together, we went well beyond locationing and eventually saw the opportunity to use this new class of at-scale data to understand the pedigree of a part from its inception, which is the very first time the first piece of raw material is loaded on the first machine, through sustainment, which is once a product has actually been delivered to the end customer and has been deployed to the field. So tracking the pedigree of a part, this is a huge statement. This takes a new class of data that has never been easily accessible by a citizen developer or by a business analyst. This is where the Thin Air plus Wiliot partnership, this is where massive IoT meets out-of-the-box visualization. So let's talk a little bit about the case study and how you get to the case study. The use cases we're talking about and discussing here require millions of data points every second. So we deploy an easy to install layered infrastructure. And this is a unique hybrid and meshed approach that has been accomplished between us, Wiliot, and even some of the new access point providers in the industry, such as Aruba, Juniper, and Cisco. So what we do is we start with thin air gateways, both thin air standard and specialty gateways, which we'll hit on in a minute. We're now able to mesh in and include integration to access points from Aruba, Juniper, and Cisco. We're also able, with integration help from Wiliot, to mesh in Wiliot energizers, or what we call bridges today. So this is the first hybrid approach where we're able to layer in active BLE, passive Wiliot BLE, or the passive Wiliot pixel, with extreme data capture, such as low temperatures down to minus 200 degrees and vibration as fast as 52,000 reads per second. This is the first time the world's ever had a view of millions of things in real time and data at this level of extreme data capture. And when we talk about extreme data capture, we're talking about abilities. So abilities range from light, humidity, temperature, vibration, all the way to 52,000 reads per second. The existence of water. We have 40 plus abilities and more than 22 KPIs that lead into advanced analytics. And they're all read by this new hybrid infrastructure approach that we've created in partnership with Wiliot. So with this customer, we deployed more than 100,000 active BLE beacons that generated real-time data from these 40 plus abilities that I mentioned. What Wiliot did was brought us the ability to grow that data set. Wiliot helped us break that barrier of 100,000 or 150 or 200,000 items and reach the millions or billions of things. This was the true enablement, or what we considered the breakthrough to reach massive IoT in today's market. So we already discussed the fact that we have 100,000 or had more than 100,000 devices already pushed out. As part of our move to the IoT Pixel with Wiliot, we created software, mobile software, that allowed us to very quickly and efficiently associate a pixel with an asset. We've gotten it down to 2 scans. Scan the QR code on the pixel, scan the barcode on the asset. We handle all of the back-end association and even the integration with SAP. We are also able, because of the Pixel IoT, the IoT Pixel, we're also able to do cluster analytics. And Bryce will demonstrate cluster analytics in a few minutes, but this goes beyond getting into a software solution and putting a serial number or a keyword of what I'm searching for. This is AI truly learning where things are and where they should be, and alerting you when things are out of place. We're also tracking forklifts. So we track forklifts through the facilities today in preparation for what we call smart routing. Today, we keep breadcrumb trails of the forklifts and where they go, but tomorrow we will understand what piece of raw material is on what machine and what piece of the manufacturing process is next, and where that piece of raw material needs to get positioned to start the next piece of the manufacturing process. We will actually begin telling the forklifts where to go, what to pick up, and where it needs to be taken. So we separate the data into what's called a transactional database, a real-time database for real-time locationing, real-time vibration, temperature, humidity feedback, real-time notification of the position of an arm. And we combine this data to get a real-time view of what's going on in your manufacturing process. Sonar is where we've democratized all of this data. Sonar is where a citizen developer or somebody from the line of business can actually visualize the data. Sonar is where you can set triggers and alerts, which are fed by our massive IoT data set. We also separate it that real-time transactional database from a data lake. And in that data lake, we get into advanced analytics like HUMSKits, health utilization and monitoring systems, where we monitor how machines should be running today. And we use AI to learn what an anomaly state looks like. Bryce will actually show you a new digital twinning capability that has been born from this capability. Something we're pretty excited about, we are nearing approval for classified areas with the Wiliot IoT Pixel. This is the point where massive IoT goes that it's never gone before. The other thing that we are nearing the approval for is the ability to send a Wiliot IoT Pixel into the field on a completed product and in or within a government project. Very exciting stuff. And we have one more announcement with the Wiliot Pixel before I turn it over to Bryce. Many of our IoT use cases from healthcare are now available. And when I say now, you can buy them today, utilizing the Wiliot IoT Pixel. So each module that we've built up in the factory that I discussed earlier builds upon itself and becomes the factory of the future. We also do that in healthcare. Each one of these specific use cases builds upon themselves and eventually becomes the hospital of the future. And with the data lake, we can get into advanced analytics. But we are pleased to announce that real-time asset location, misplaced asset detection with AI, that's our cluster analytics, and human implant location monitoring are all available today with the Wiliot IoT Pixel and in partnership with Wiliot. So with that, I'm going to turn this over to Bryce and have him do a real-time demo of our product. Bryce, over to you.
Thank you, Brian. So this is Sonar. This is our web application where we allow our customers to visualize those millions of data points that they collect every second. So what we allow our users to do is actually get a top-down view of whatever layer they're looking for. So they are able to start at map views if they would like, go to a floor on a specific building, in a warehouse, see all of the assets that are currently located on that map, be able to see which ones are online, offline, get a quick view of if they are, what their temperature is, what their location is right here. We also allow our users actually to draw zones or what we call places on these maps so they can filter down their location a little bit better. This is used in inventory management. So some of our clients actually use this to hit our APIs every night to pull what assets are in what storage room every single night. It's also used if I want to quickly visualize, show me all of my assets in center workspace, which is a zone drawn in the middle of that warehouse I just showed you. This pulls that up. This gives the user that view of exactly what assets are in this zone at this moment. From here, our users are able to drill down into specific assets. So if I go to this pallet trolley here, I'll see its specific location. And this is an asset that we are actually using the Wiliot Pixel for tracking. So if I go into this asset here, I can see all of its movements from today. I can also go back in time if I would like to go see the history of its movements. But if I just need to know today, I can actually step through all of this asset's movements as it's moved through this warehouse this day. So I would have all that data right here. It's easily, readily available for anybody to come in here and pull whenever they would like. I'm also then from here able to set triggers and alerts. So from here, I can go up to this little plus button, create a bulk trigger. We call them bulk triggers because you can create triggers on a single asset or on a group of assets, as many as you would like. That way we make this massive IoT much more simple. So I can give it a name, a description. I can also set severity levels. So because a lot of our clients are in the manufacturing space, they do actually want positive triggers. So we have mild, moderate, severe, positive. The reason for positive is if it reaches a certain zone for a certain period of time, it's a positive that it reached that stage of the manufacturing process, but they want a trigger to go out to alert users that it's reached that point in the process. I can add keywords to make searching and filtering much easier as you've created hundreds of thousands of triggers. And then we have our trigger types. So we have all the abilities that Brian hit on earlier, where you can set triggers on those. We can also do the in, not in. So if I want to know when an asset entered a certain zone on a certain map, I can be alerted of that very quickly and efficiently. Now, I can search the map. I can select a specific place. We also have the ability to set duration. So what duration means is if I put this at 30 minutes here, so now this asset needs to be in or not in the zone you've selected for 30 minutes before something would happen. So if you wanted to make sure it's been there for an extended period of time, I would set that here. We also have a feature called Autoresolve. This is normally used for lower value assets. If it's turned off, which right now it's not enabled, so it's off, this means a human has to go in and resolve this trigger. So if this triggers off, a user needs to go find this asset, obviously using Sonar, and put it back where it needs to go, and then give feedback as to why it was there or what they did to fix this issue. If it's a lower value asset, they can enable this auto resolve, and maybe I set this to 60 minutes. So what this would mean is if it goes into a certain zone for 30 minutes, a trigger will go out. If it goes back into the zone it's supposed to be in for 60 minutes or 1 hour, there will now resolve itself and also send out an email to all users that have been added to this list as well. So you'll still have that history of what happened with this asset. And it's very simple to add the users you would like. So I'm adding myself here, so I can add as many as I would like. We also can then say, what assets is this monitoring? I could have it monitoring all of my assets, ones that have a specific identifier, have a certain keyword, have a name contains. So if you have a certain type of assets, maybe your calipers all have similar type names. I could put this on all calipers, or a single asset. If I just want to monitor, create a very specific trigger for a single asset, I can do that here as well. And then the last one is subscriptions. So we have the ability, obviously we're integrated with many different systems that are out there. SAP was one that was mentioned earlier. You can send this trigger information to other systems. So maybe it's not one that we're heavily integrated with and you just need this trigger information, you can do that from here. You can add that subscription. So when this trigger goes off, it simply sends this data to that other system to be consumed. And then from here, I was also going to highlight today the misplaced assets because that was mentioned in the PowerPoint slide. So this is actually here, if I go to this map we were showing earlier, this thin air HQ, we have Wiliot pixels on a number of our calipers here that we're using in our office. So what this allows our clients to do is actually get ahead of lost assets. So instead of just ordering when an asset is missing or lost or they believe it's lost, what we have are algorithms that learn where you store things over time, and we learn where clusters are. So we obviously see that there's a cluster of calipers here and that there's one misplaced asset. So we learn over time, the longer this runs, where these are stored. And so if there's multiple storage places, you would see multiple clusters of gray, and then you would just see little red ones sprinkled where there are misplaced assets. So this just helps our customers get ahead of what's actually lost. And then this was the web demo. We do also have a mobile app and an advanced asset page, which was hit on earlier as well in terms of the HUMS kits or the digital twinning. So with our mobile app, you'll have majority of all the features I just hit on actually right there, as well as a few others in terms of setup and configuration. So you can visualize your maps, see temperature, see location of your assets, drill down to that specific location by zooming in on the map. And then we also have that digital twin here, the health utilization and monitoring system as well for the more advanced assets that have many different sensors attached, where I can normalize some of this. So this has KPIs, temperature, humidity. You can actually normalize this so you can actually compare them in a realistic way. Zoom in on the specific areas you're looking to compare, share these screenshots or share these images with these graphs to other users as well. And that's it from me. So from there, back over to Brian.
Thank you, Bryce. Let me bring all this home. So we built at Thin Air, we built an infinitely scalable platform, and we built software that understands how people or how humans want to interact with millions of data points every second. The Thin Air Wiliot or partnership and bringing the IoT pixel into the picture is what truly unlocked massive IoT for us. The form factor, the price point, that's what unlocked the ability to go from hundreds of thousands of things to millions of things and billions of things. And the data from millions of billions of things is far more valuable. The more data, the more intelligent we can make the AI models. The more data, the faster we can teach the models. It's proven to be a very powerful partnership for us and for our customers. I will say everything we outlined, we do in the aerospace industry, DoD, CPG, and healthcare. We also do this for space agencies. So we're pretty excited about the fact that things that we help build are no longer even on this planet. And we work every day to try to be Earth's #1 AI and IoT company. So thank you, Wiliot, for inviting us to the webinar, and we'll be excited about answering questions.
Thanks, Brian. That was great. Now, next up is Jonathan Webb, who's Director of Product Development at Cassie. And Jonathan's going to give you a run through of some amazing equipment and engineering that has been developed and integrated with our product at the request of one of the largest companies in the world. Jonathan, over to you.
Thanks, Steve. Hi, everybody. My name is Jonathan Webb, and I am the Director of New Product Development at Cornerstone Automation Systems, also known as Cassie. It's a pleasure to get to talk to you a bit about Cassie and our relationship with Wiliot. So who is Cassie? At the end of the day, Cassie is an automation company trying to make processes more efficient for our customers. We do this by creating both hardware and software, and by providing assembly and installation support for their automation. These services allow our customers to move merchandise, manage inventory, and serve their clients more efficiently within the walls of their stores, their back rooms, and their warehouses. You can see a few of the key highlights about Cassie here. I'll just touch on a few of them. We've been delivering turnkey systems since 2002 to over 700 customers. Our technology can be found all over the world, and it includes some of the most recognizable brands. It even includes 40% of the top 10 companies listed in the Forbes Fortune 500. And FANUC has recognized us as a top robotics integrator. So what does Cassie really do? What do we excel in? The core distinguishing characteristic of Cassie is that we're very nimble. We create fast solutions, and we're very customer-centric. We focus our solutions in two areas. The first is creating custom automation systems or assembly solutions specific for our customers. The second is in developing Cassie's standard products to address the retail, warehouse, and e-commerce industries. We maintain our nimble culture in a few ways. Most importantly, we partner with our customers at every stage in the process. We start from the problem that the customer needs solved. We work with them to create the best solution. Then we install the machine at the customer's site and continue to provide field support after delivering the system. We have a full team of engineers in-house that can respond rapidly to address any part of the scope of a project. And we design, build, and test all of our products in the US. There are 3 market segments that Cassie supports. These are retail, pharmacy, and warehouse and e-commerce. And I'm going to quickly highlight a few of the key technologies in each of these segments. We can see here the inside of a retail store. And as you can see, we've developed technologies to assist in both the sales floor and the back room. We have a good understanding of standard work environments and the needs of the company associates, but we're also sensitive to the shopper's experience as well. At the front of the store, we've been heavily involved in custom design of self-checkouts. For these devices, we can design and build a turnkey solution, or we can work with the retailer on any portion of the work along the way. And I'll give an example here. We have a customer for whom we do only the electromechanical assembly and testing of their self-checkouts. On the warehouse and e-commerce side of our business, we're focused on the first 100 feet and the last 100 feet of the warehouse. On the left is our automatic box cutter, which safely and dynamically cuts the tops off of boxes. We also do contract support services like installation, assembly, and testing. For example, we're scheduled to install over 2 million bin locations this year for our partner in the ASRS space. And as shown in the final picture, we sell a Cassie-developed powered flexible conveyor, as well as a rigid 24-volt DC conveyor. So the image here is of the Cassie box decanting system. We have a very simple solution to the complex task of removing items from boxes. This machine fills totes with product, which ultimately is transferred to the client's ASRS. In this receiving system, our equipment assists in unloading a truck. We transfer items out of the truck and then sort them by location. And for systems like this, we see excellent truck unload efficiency gains. And then finally, we've been working in the pharmacy automation space for about 10 years now, both in the US and in England. We have developed solutions to some of the choke points in order fulfillment. Most notably, we can very precisely place labels on boxes at 80 boxes per minute. We can also consolidate medications by patient, automatically bag those medications, and then send those medications to the store. So that was a bit about Cassie, but we still need to address why I'm speaking with you at this Wiliot hosted event. Well, it's because there's a clear benefit of partnering Cassie's ability to make products move with Wiliot's ability to simplify tracking the inventory state of these products. By merging these two capabilities, there is an opportunity to uncover a new level of advancement for inventory management in retail and e-commerce. The key to inventory management is to identify the merchandise at various states within the warehouse. Traditionally, this is performed through barcodes and barcode scanners. This technology requires line of sight in order to work, meaning that the scanner must be able to see the barcode in order to read it. Wiliot, however, is a non-line of sight technology, meaning that the tag does not necessarily need to be visible in order for the item to be identified. This has some major advantages, which you can see here on this slide's chart. But okay, so rather than reading the table for you, let me just give a few examples of how non-line of sight would positively impact the systems that we work on. So let's imagine a system in which a box is placed onto a conveyor. That box is moving down the conveyor where it's scanned with a barcode scanner pointing at the side of the box. So the operator is there, he's going about his business, he's picking up boxes, he's placing them onto the conveyor, barcode labels on the side, no problem. Then the operator is momentarily distracted and he accidentally places the box on the conveyor with the barcode facing away from the scanner. Once this box reaches the scanner tries to scan the box, but can't see the barcode. However, if this same distracted operator were to place a box with Wiliot's BLE tag on the surface facing away from the bridge, there's still a good chance that the box would be identified because it's a non-line of sight system. Wiliot's technology could make inventory tracking less prone to operator error. Now let's take this example a little bit further. Let's say that the box being placed on the conveyor contains ice cream. The warehouse manager wants to know if the ice cream has ever melted along its journey to the warehouse, then to remove it from inventory if it has. Since Wiliot's BLE tags have intelligence built into them, they monitor key metrics of the box's environment, such as temperature. They can provide information of whether the ice cream was ever exposed to above freezing temperatures. Barcodes do not have this ability. So Wiliot provides a very nice feature to ensure that only good quality ice cream reaches the customer, which is important. Wiliot was introduced to Cassie by a very influential mutual customer. Because of prior projects that Cassie executed for this customer, the client recognized that Cassie could help bring the Wiliot technology to life for the client's applications. Since that point, Cassie and Wiliot have been exploring how our technologies merge together. To tell that story, we've developed a case study of how integrating Wiliot bridges into Cassie's conveyors, sortation solutions, and box cutting solutions could be done seamlessly and potentially give a step change in inventory visibility to the warehouse. And as a data point to my earlier comment about how nimble Cassie is, for this case study that you're about to see, we designed, fabricated, and installed the custom equipment in less than 3 weeks. So let's see a video of this system in action.
Hey, 3 weeks. 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 3
What you see here are hardware bins for the assembly team. The bins with the red tags are out of stock, and they are limiting the team's ability to complete the work. The replacement hardware is on a delivery truck that's just arrived at the warehouse. We're going to watch how that inventory is tracked throughout the warehouse. Here you see that a Wiliot bridge has been mounted to a forklift with a Cassie installation kit. As this forklift begins to pull pallets off of the truck, the bridge sends RF waves to energize the BLE tags on each box. These individual BLE tags then send the box's identity back to the bridge. In a traditional system, each box would need to be removed from the pallet and individually scanned. But here you see that no additional operator effort is required. The pallets are now being relocated to a box cutting area where the items inside the boxes will be removed. This Cassie belt-over roller conveyor has been integrated with single band bridges to monitor which boxes have been dropped off in the cutting area and are ready to be cut. And this is a top view of the Cassie box cutting machine, which is one of the flagship products for Cassie. It's being used all over the world, and it cuts up to 950 boxes per hour. Here, the Cassie O-ring conveyor has a dual band bridge, which changes the box's inventory state to cut complete. In this area, the unidentified white boxes are removed from the brown BLE tagged boxes. And so after this point, these decanted white boxes then need to be relocated into a new area of the warehouse. Here, the BLE tags will be applied to the boxes, and they will be sorted by inventory location by this system, the Cassie sort. The Cassie sortation wings have integrated Wiliot bridges to track when a box has been sorted. These single band bridges are very small, and so they can be discreetly located on the machine. Here we see Cassie's Agility Flex conveyor beginning to move the boxes through the Cassie sort. The boxes will move from this conveyor through a scan tunnel and then finally to the sortation area. The Cassie sort is capable of sorting up to 30 boxes per minute. And these boxes are sorted by color in this case. This is based on the content's final location. And once the boxes are in the sortation area, the bridges under the folding wings will read the BLE tag on the box, and the inventory state of the box will change to sorted. These sorted boxes now need to be moved to the correct stocking location in the warehouse. This Cassie Smart Cart incorporates a dual band bridge to indicate that the boxes on the cart are now being transferred to their stocking location. The process that we have seen has tracked these boxes and their contents across the warehouse while moving it from various inventory states. This case study demonstrates some of the advantages of merging Cassie's automation with Wiliot's inventory management technology. And as you can see, the hardware is successfully transferred to the correct bin location, and the assembly team may resume work with these parts. I want to quickly highlight the technology that was inside the video. There are two categories of equipment here: mobile machines and static machines. The forklift and the smart cart are both mobile, meaning that they can move around the warehouse. Here, I want to note that the bridges can be mounted to these machines and either hardwired into them or operated by battery. For the static location devices, we've been able to integrate both the single band and the dual band bridges into our conveyors quickly and easily. We've done this as well on the folding wings of the Cassie sort. And because of the single band bridge's size, it can be discreetly located within the automated equipment, which is really nice. I want to thank you again for the opportunity, and please reach out to Cassie for any product inquiries or questions at the contact information that's shown here. Thank you.
Thanks a lot, Brian, Bryce, Jonathan. It's very exciting to have been working with you all this time and seeing this presentation showing what we've accomplished just now and where we're going to be able to take that in the future. So if we were in person, I would ask for a round of applause because I think it was great. And we're now going to start looking at a few questions that have been asked in the chat. So thanks a lot for the audience. We see a lot of questions, some were answered, some have not been yet. So I'll start with, I think, an overarching question many people are asking in different format, but why Wiliot? Why did you choose Wiliot? So maybe we can start with the thinner side. Maybe Brian, you want to say a few words? I think you alluded to it, but maybe you want to add a few words on why Wiliot was a good solution for you.
Sure. So for us, the IoT Pixel was an accelerator to achieving massive IoT. We had invested millions of dollars building an infinitely scalable platform, and we have tuned Sonar for massive IoT. But the form factor of the IoT Pixel and the fact that you guys were forward thinking enough to come up with a dual band version, it opened up a number of at scale use cases for us. So for us, it was the final puzzle piece for massive IoT.
Excellent. Thanks, Brian. And on the Cassie side, I think maybe Richard, you would be best to say a few words about why Wiliot?
Absolutely. Thanks, Matthew. Yeah, Wiliot, obviously, as Jonathan mentioned, was brought to us by one of our biggest and best customers. And so it became taking Cassie's capabilities in the warehouse and automation space and really utilizing the latest and greatest technology in terms of product identification. And so it's become a great partnership that's a great technology that's easy to implement and certainly scalable in this world. So thank you for that.
Oh, thank you both. I think for your trust and for working with us to make it possible. Another question that I think is coming probably from some of what you mentioned, Brian, on the thinner side, but something you referred to was around choke point or how maybe we're looking at going beyond choke point. And I'm wondering if somebody on your team, I'm thinking maybe Taylor, you could talk a little bit to that. What does that mean?
Yeah.
Beyond choke point?
Sure. So, we've kind of gone beyond active beacons, right? We're to this point where we're at these battery-free beacons, and we have customers that are wanting this sort of thing that they got from active beacons. So we created this kind of new infrastructure, the layered infrastructure. So like Brian talked about, it's the access points from Aruba, Juniper, Cisco, it's gateways, it's Wiliot devices, and it really allows us to utilize all of that to track the IoT Pixel in larger, more open areas rather than just choke points, right? So it's it's everything coming together to track pixels in wider areas, not just choke points, but then also utilizing the software that we built. So location algorithms, all of that layered together, it really supercharges what you can do with the IoT Pixel. Yeah.
That's exciting. Could I maybe say that it's partly thanks to like the Bluetooth layer, which is becoming very ubiquitous and part of those access points you mentioned, and of course your expertise on the additional application layers that enable the customers to use that data. Excellent, thanks, Taylor. Another question that is interesting, and it's interesting because we see those questions often when we talk with customers, with partners, and inevitably we see it also in the Q&A here. It's more along the lines of performance and how to make things work better. I think in some other space, people talk about scan rates, which I don't know if it's the right way to think about it, but I know Cassie did a lot of advanced testing in the projects we have been scaling together. Maybe Jonathan, you can talk a little bit of some learnings on how to get the best out of the technology.
Yeah, absolutely. So I think to kind of dive into that question, you really need to understand how the battery-free BLE tag and the bridge interact with each other. So that the tag does not send a message instantaneously back to the bridge when the bridge sends energy to the tag. So that energy builds up over time inside of the tag before the tag sends that energy back out to the bridge. And increasing the read rate of the bridge really correlates back to making sure that the tag sends a response to the bridge while it's within the bridge's range. And there's really, there's two primary variables that affect those rates, those are exposure time and signal strength. And so I think increasing the amount of time that the tag is exposed to the energy can be done in a couple of ways that we've seen. So you could slow down or stop that product in front of the bridge to increase that time, or you can place multiple bridges along the flow path of the product. So think like a bridge on a conveyor, on several conveyor belts as it's moving along a path on the conveyors. And that second variable is increasing the strength of the energy that the tag is exposed to. And there are a few ways to do that. One is by making sure that the bridges are placed in multiple planes so that any polarity issues would not affect the tag. We would keep the distance between the bridges and the tags really close. And then, finally, just making sure that you don't put the bridges really close to each other because there can be some interference there. So those are a few of the ways that we would use and have used to increase those scan rates.
No, great. Thanks, Jonathan. And it's interesting to hear both part of the answer to those questions from both Sonar and Cassie, in that it's a little similar in a way. You can get a wider coverage and in a way, if you want to capture information following the product, maybe instead of, let's say, a choke point approach or a manual kind of approach that is sometimes used, seems to be very beneficial. I want to be mindful of everybody's time. I think we're already over, but we will send the recording of this webinar to everybody with an email afterward. We will also follow up on some of the questions that unfortunately we may not have the time to answer just now. We will have another very exciting webinar coming in a month-ish, maybe a little more in time, around a topic that we are heavily focused on, the returnable transport item industry. You can think of pallets, plastic crates, and so on and so forth. And we're fortunate to host some of the leaders in that space. So stay tuned for this announcement. We hope to see everybody again then. And again, major thank you to the Sonar and Cassie team. And I look forward to continue working with you and really take that to the trillions, hopefully soon, that we're aiming for. Thank you, everybody.
Thank you.